All right, Algebra 2, we're going to move on to section 8.4. We're just going to work on the first part, which on your paper it doesn't say part 1 and part 2. But today for part 1, we're going to work through example 5, and that's where we're going to end. So we are talking today about logarithmic functions. And here it says that every exponential function, remember, it passes the horizontal line test. Now, just to give you a reminder of what the horizontal line test did. Earlier in the year, we learned about vertical line test. A vertical line test proves that what you have is a function. The horizontal line test proves that the inverse of what you have is a function. So vertical line test proves that what you have is a function. The horizontal line test proves that the inverse of what you have, remember inverse means when you switch the x and the y, the inverse of what you have, that it is a function. So the exponential functions, they all pass the horizontal line test, and so that means that their inverse function is indeed a function, and it is called the logarithmic function. That's probably a word you've not ever heard before. What we're going to be practicing today is going from one form to the other. So this is what we've been working on the first half of the chapter. We have been working on exponential functions. Remember, that just means that your exponent is a variable. Now, obviously, right now you see 3 different variables, right? But normally this would be a number. B just stands for base, okay? So you might have 2 to the x equals y, and your exponent is a variable. So that's why we call that exponential form. But we are going to be changing exponential form into logarithmic form, and this is where we use the abbreviation for that word. So we call it a log. So your base becomes the base of the log. So this would turn into log base b of y equals x. I'm going to write that down. I'm going to write it from left to right. So this would be x equals log base b of y. X equals log base b of y. That's how we would read that out loud. So it is important that we know how to say it out loud. Now what we're going to work on in the first example here is taking something that right now is in exponential form, and we're going to turn it into logarithmic form. So the first thing that I like to ask myself is, what is the base? Right? For this problem, 10 is the base. The 5 is the exponent. The 10 is the base. So let's see how we can rewrite that. So this is going to be log base 10. I'm taking the base, I'm plugging it in for b. Log base 10. All right. Now the exponent, let's look at the exponent. The exponent is always on the other side by itself. So that means for the equal sign over here, the exponent is going to be on that side by itself. And so what's going to come after log base 10? That's going to be this number right here, 100,000. So I'm going to say that log base 10 of 100,000 equals 5. So whatever this is equal to, that is always the exponent. All right, let's try letter B. What can you identify as the base? The base is 2. So I've got log base 2. Now remember, we said that the exponent is always on the other side by itself. So my exponent of 3 is going to be behind the equal sign. So over here I'm going to say log base 2 of 8 equals 3. Now if you want, you can put the equals 3 over here. It doesn't matter what side you put that equal sign on. They're both okay. All right, letter C. The 1/3 is the base. The 2 is the exponent. So let's see if we can figure this out. We're going to have log of base 1/3, or log base 1/3, what's going to go on the other side? Well, remember the exponent is going to go on the other side, and our exponent is a 2. So back here, we're going to have 1/9. So the way I would read this out loud, I would say log base 1/3 of 1/9 is equal to 2. So all we did there was just change it from exponential form to logarithmic form. Now we're going to go in the opposite direction, which actually I think is even easier. So as we look at letter A, the way that I would read this, if I were going to read this out loud, I would say log base 2 of 32 is, or is equal to 5. Now if you can read it out loud, it really helps you rewrite it. What's the base? The base is 2. Remember, what's on the other side of the equal sign all by itself? That's always the exponent. So this would be 2 to the 5th power equals 32. Well, you can check that. 2 times 2 times 2 times 2 times 2 is indeed 32, so it works out. All right, let's look at this next one. Log base 5 of 1/25 is -2. Now, I don't expect y'all to write those words out. I'm just doing it for the purpose of the notes. If you want to write it out, though, feel free to. So our base is 5. Remember, the exponent is what it is equal to. So the exponent is -2. And we're going to set that equal to 1/25. Again, for this particular one, you can check it. Remember, we learned that a negative exponent doesn't mean that your answer is negative. We would flip that. So we would turn that into 1/5 to the positive 2, which turns into 1/25. So this does check out. All right, that's the last one. Again, I'm going to write this as I say it, but you don't have to unless you want to. So this would be log base 7 of h is g. Log base 7 of h is g. All right, what's the base? 7. What is the exponent? Remember what it's equal to. So g, and then we're going to set this equal to h. Now this is one that you can't check because these aren't numbers. So you have to hope that you know correctly how to change it from logarithmic form to exponential form. So right down here it says, it is important to remember that log base a of x is an exponent. The answer to every log is the exponent, which is what I've been saying down here. The number that's by itself. The answer to the log is the exponent. If you can remember that phrase, the answer to the log is an exponent. The answer to the log is the exponent. The answer to the log is the exponent. I know I sound like a broken record, but if you can remember that phrase, then now you know that whatever it is equal to is always the exponent. Now we also have what's called a one-to-one property of exponents. And it says, if b to the x equals b to the y, then x equals y. And I know some of y'all don't like math if there aren't numbers in it. Basically, this is what this is saying. If these bases are the same, so if bases are the same, then guess what? Those, what were they? Those were the exponents. Then they are equal to each other. Then exponents, I'm going to abbreviate, are equal. So if you have the bases on each side the same, then that means the exponents on each side are also going to be equal to each other. All right, now here's where we're going to spend the most of our time. For example, 3, 4, and 5. What we're going to be doing is we are given a problem with logs. And we want to find out what the equal or what the x is, okay? And this is where we're going to be changing it to exponential form. So follow along with me on this, okay? First thing I'm going to do for letter A is I'm going to write equals x, because that's what I'm trying to figure out. What does it equal? So I'm going to take this in logarithmic form, and I'm going to turn it into exponential form. So remember, if I were to say this out loud, this would be log base 5 of 25 is x. Okay, so what did I say the base is? The base is 5. Now remember we learned earlier that the answer to a log is the what? Is the exponent. So that means x is the exponent. And we're going to set 5 to the x equal to 25. Now for this particular problem, I think a lot of y'all could do it in your head, and that's awesome. But I'm actually going to go through the steps of why the answer is what it is so that I can show you how it works. So remember we just saw a minute ago this property right here that said if the bases are the same, then the exponents are also going to be the same. They're going to be equal. So what I would ask myself is I would say, hey Wingard, can I rewrite so that these have the same base? Well, what do I know? I know that 25 could be written as 5 to the second power. That's something that I should know, right? 5 times 5 is 25. So this is where I get to use that property. If the bases are the same, and that's what I did, I changed them so they have the same base, then that means that my exponents are equal to each other, and that means that x is equal to 2. And that is my final answer for A. So let's do that again here. So I'm going to set this equal to x, and then I'm going to turn it into exponential form. So first I need to figure out what is my base. Well, how would I read this? Log base 10 of 1 equals x. So my base is 10. Remember, the answer to a log is the exponent. What's the exponent? X. And I would set that equal to 1. All right, well, tell me what you know about raising 10 to a power and it equaling 1. How can you do that? Could you do a positive number like a 1? No, because 10 to the 1 would be 10. Could I do a negative 1? No, because then you would flip it and you would get 1 over 10. But do you remember we learned a rule that says that you can raise anything to the 0 power and it equals 1. So here's what that means. Now that my bases are the same, all I did was I replaced the 1 with the 10 to the 0 power, because raising something to the 0 power equals 1 every time. Now I get to set those exponents equal to each other, and that means that x is 0. All right, same thing for letter C. Here we go. Log base 3 of 81 equals x. So my base is 3. My exponent, remember the answer to the log is your exponent, and we're going to set that equal to 81. Well, let's talk about 81. Let's break that down. 81 is divisible by 3. It goes in there 27 times. 27 is also divisible by 3 9 times, and 9 is divisible by 3 2 times. So that turns into 3 to the 4th power, and some of y'all may have remembered that and might not need to do any work. So now that my bases are the same, that means my exponents are the same, and so x equals 4. All right, let's take a look at this next one together. I'm going to try to walk through it slowly because it's a little bit trickier. So this is log base 8 of 1 over 64 equals x. What was the base? 8. The answer to a log is the exponent. What's the answer to our log? X. So I have 8 to the x power equals 1 over 64. Well, here's what I would ask myself. What do I know about 64? Right now I'm going to ignore the fact that it's in a fraction. Just ignore that and focus on the number 64. I know that 64 is the same thing as 8 squared. Now the problem that I have right now is my bases are not the same. My base over here is an 8. My base over here is a 1 over 8. I don't want to have a 1 over 8. I just want an 8. So remember we learned that I can move that up. But when I move it up, it changes the sign of my exponent. So my exponent was a positive 2. I have now turned it into a negative 2. Remember when you move something from the denominator to the numerator, it changes your sign. We started off with a positive exponent, but I now have changed it to a negative. And now that the bases are the same, that means that the exponents are the same. So I get that x equals negative 2. So there is my answer for letter D. All right, example 4. Log base x of 49 equals 2. What's the base? The base is x. What's the exponent? Remember, the answer to the log is the exponent, and this too is the answer to the log. So we get x squared equals 49. How can I rewrite 49? What do I know about 49? Now let me real quick, let's go back here. Because some of y'all might know that off the top of your head, but let's go back here for a second. Remember we saw this one-to-one property, and it said if the bases are the same, the exponents are equal? The converse of this is also true. If, and this is good to know, if the exponents are equal, then the bases are the same. So vice versa. You can flip that sentence around. If the exponents are equal, then the bases are the same. Why did I want to tell you that? Well, right over here, my exponent is a 2. How can I rewrite 49 so that it has an exponent of 2? 7, right? 7 squared is 49. So if my exponents are the same, then my bases are equal, and x equals 7. All right, we're going to use that same knowledge for letter B. So log base B of 1 over 16 equals -4. What's the base? The base is x. What's the exponent? It's the answer to the log, which is -4. And we're going to set that equal to 1 over 16. All right, so here's what I'm thinking in my mind. I want to rewrite this over here so that it has the same exponent that this side has, which is a -4. So I might go through a couple of steps. So let's just first ignore the fraction, because I know fractions kind of wig some of y'all out. Let's talk about 16. What do you know about 16? Well, I know that 16 is 4 squared. What's my problem? Those aren't the same number. So what else do I know about 16? Well, let's talk about 16. 2 can go into 16 8 times. 2 can go into 8 4 times. 2 can go into 4 2 times. So what if I wrote the 16 as 2 to the 4th power? This is looking a little bit better. But my problem now is that I need to have an exponent of a -4, not a +4. Well, just like we saw in the last problem, I'm going to move that up. So I'm going to have x to the -4 equals, I'm going to move this up to the numerator, so 2 is going to go in the top, but that +4 exponent now turns into a -4. And now we're back to the rule. If the exponents are the same, then the bases are the same. And my answer is x equals 2. All right, letter C. I'm all over the place, so I'll just write that. All right, log base x of 1 over 125 equals 3. All right, what's the base? X. What's the exponent? The answer to the log, which is 3. So we're going to set that equal to 1 over 125. So remember the goal, people. We want the exponents to be the same. So I'm going to focus on that 125. Right now I'm just ignoring the fact that it's in a fraction. 125, definitely divisible by 5. 5 can go into that 25 times. And 25 can break down into 5 times 5. So instead of writing 125, I'm going to write 5 to the 3rd power because I had 3 5s. All right, good news. Look at my exponent. It's a 3. This is a 3. That is the same thing as what if I put the 3 on the outside, and inside what do I still have? I have the 1 in the top and the 5 in the bottom. Do you see what I did? I just took this exponent, I moved it to the outside. Now that my exponents are the same, that means my bases are the same. And so x equals 1/5. All right, letter D. Log base x of 64 is 1. So the base is x. The answer to the log is the exponent. So my exponent is 1, and we're going to set that equal to 64. This currently, I don't see an exponent, but what's understood to be the exponent if I don't see one? A 1. So my exponents are already the same. That means my bases are the same, and the answer is 64. All right, last example that we're going to go over today, example number 5. Again, we're going to start it the same way. We're going to take what was written in log form, we're going to turn it into exponential form. So the way I would read this for part A is log base 3 of x equals -3. What's the base? 3. What's the exponent? The answer to the log, which is -3. And then we're going to set that equal to x. Now here's the really good news for this one. X is already by itself. So all you have to do is simplify 3 to the -3rd power, which is good practice of our exponent rules. What if we don't want that negative exponent? We flip it, so we turn it into 1/3 to the +3rd power. And then we're going to simplify that again, because 3 to the 3rd power, 3 times 3 times 3, is 27. So we end up with x equaling 1/27. All right, letter B. Log base 5 of x is 4. So the base is 5. The exponent is the answer to the log, so it's a 4. And then we're going to set 5 to the 4th equal to x. So all you have to do is 5 times 5 times 5 times 5, which is 625. All right, log base 27 of x is 1/3. What's the base? 27. What's the exponent? 1/3. And then we're going to set that equal to x. Now earlier this year, and it's been a while, well, it hasn't been that long, we've learned what happens if you have a fraction for an exponent. And remember that we learned that we're going to rewrite this in the form of a radical, and the denominator of that fraction is the index. So I'm going to write a radical. The denominator is 3. That's my index. The 27 is what goes underneath it, and that exponent, or that number in the numerator, is your outside exponent. What does this mean? Remember, this means what number can we multiply by itself 3 times to get 27? And the answer to that is 3. And 3 to the 1st power is 3. And that's your final answer for letter C. All right, last one. Log base 10 of x equals 0. Base is 10. Exponent is the answer to the log, so 0. And we're going to set that equal to x. 10 to the 0. Well, if you raise something to the 0 power, you get a big fat 1. So x equals 1. All right, so that takes us through part 1 of 8.4. Your homework assignment is a worksheet. You need to have that finished by the time we meet on Zoom tomorrow. And then tomorrow we'll take a look at that together during our Zoom session, and then you'll have a quizzes assignment due by tomorrow night. So I look forward to seeing you guys at the Zoom session tomorrow morning.